Jacob doing the uppy-down elevator bit that we can use to manipulate the coral. So we settled on a lead screw design with this nice piece of all thread we found. So with that in mind, it's going to be based around a couple pieces of aluminum tubing. You can see, probably not, that it moves up and down. Let me manipulate it for you here. And voila, it goes up and down. It's a two-stage system, so we're gonna have a Neo 550 driving the second stage and a regular Neo driving the first stage. And it's gonna be great. Off to the next guy.
Well, prototyping the intake sub-team. Our original idea that we first drew an hour after kickoff was to have the robot have an arm that intakes the ball off the ground and then potentially outtake on the other side. But then during some of our prototyping that should show the wood video soon, kind of found that we can just use the arm that we want to intake the ball to also outtake the ball. And we considered a few different pivot points that we want to move that arm, and then also considering whether we even need to actuate the arm up and down or not. We kind of determined the best course of action for us would be to both actuate the arm, and we chose a pivot point that worked best. And then Nathan can show the CAD here.
Okay, so there's the algae, and our pivot comes down. It's basically a touch it, own it intake.
You're gonna need to go closer.
We have big green wheels, not in the CAD right now, but you'd see it in the video. Basically, this just comes down, it's spinning, and then it just comes into our robot. We still need to build out like a ramp system. That's what we had in our video. And then it just sits there, and we just reverse the wheels, and it scores out into the goal. And we starting our design for how we're gonna make this move. And yeah.
This is good. Okay, and then this is the red dongle. Oh, that's plastic. Is that the right dongle for yours? No, you said Jacob.
So this was the initial prototype for the end effector. This was supposed to go on the end of the elevator mechanism. The idea was that it could initially grab onto the algae and then kind of pull on this pulley right here to, in essence, actuate what we call the finger. This would allow it to have pretty secure control of the algae while it's moving around the field. And we ended up really liking this idea. The only thing we were kind of hesitant about was the whole string mechanism. So instead, what we're the mechanism we're kind of going for is we're adding a motor to pitch the entire mechanism on the back, and then a small servo right here to actuate the finger. So we did a lot of work on the CAD, and then I can present that briefly. Let me know if you can see this well. But we're using a Neo 550 to actuate this axle. And then we're using a 3D printed linkage to move this larger axle right here. This is connected via linkage, which is also 3D printed, to this servo motor right here. This servo motor is then connected to what we're going to make a 3D printed finger. Maybe this one's going to be a little more thematic. You know, we're calling our robot Poseidon, so maybe like a trident of sorts. But yeah, that's the end effector so far. And yeah, we're gonna 3D print it and see where it goes.
Hey, this is Jared. I'm here with the chassis. So originally we had tank drive. You've seen it on all of our previous years' chassis. And this year we thought that we should retrofit for something with a little bit more maneuverability. So we are switching to Mecanum, and then we have these Neo 550s. So this has been a bit of an undertaking, especially because it's now 3 days, with the robot in 3 days. So these are Mecanum wheels that we just had lying around. They're from a different project, RoboMaster, and so yeah.
Hello, my name is Anthony from the software team. And in terms of software, one of the things we've been working on today is rewriting our drivetrain code for Mecanum Drive. As Jared mentioned, we're switching from tank drive to Mecanum this year, so we've been working on rewriting our code for that. And we've also started looking into Path Planner because if we have time, we'd like to look into using Path Planner for autonomous paths.
Yeah, so right now we're using a Orange Pi 5 flashless photon vision, and we're using that with just an Arduino cam. And we're going to use April tags for just April tags. And we're working on software to just tune it right now and see how things go.